Hello.
Hey Maris, how are you today?
Pretty good.
All right, good to hear. Looks like you might have a test upcoming. Is that correct?
Yep.
When
Tomorrow.
tomorrow? All right. Okay, well, just a reminder, we are not going to meet next Wednesday, but next Monday is kind of normal plan. So plan on that. But let's get you ready for this test. We've been really working hard on triangle stuff. So uh, let's get going. Let's get going on this. How do you feel heading into the exam?
Pretty confident.
Good. And how's your grade right now in math class?
It's like a C or B.
Okay, great. All right. We'll keep up the effort here. Maybe we can push you over the edge to a B here before the semester's end. Okay, we've been doing this for a while now. What are all the theorems that can be used to prove triangle congruence? Do you remember? Can you give me any of them?
Is it like the three-letter thing?
Yes, exactly.
SAS, A, SA, HL, SSA.
Nope, there's no SSA.
Oh,
That one is not allowed.
uh, AAS.
Okay, and then one more. I usually write it at the top.
SSS.
Good, really good. Okay, I would write that at the top of your paper when you get to the test, if you can. That way you kind of know what to look for. All right, any questions on that before we begin with the rest?
No.
Okay. All right, so problem number 2A. So we should either first decide reflection, rotation, transformation. And I guess it could be a combination thereof, but like imagine going from the one on the left to the one on the right. Do you see a way to do that? I guess it's a single transformation.
I
This one's pretty
think
hard
it'd
to see,
maybe be a
actually.
rotation.
Yeah, if you were to rotate about that point right there, I think you might get it. Would that look, do you feel like that would do it?
Yeah.
Okay. So that might be one to ask your instructor about. It's not exactly the easiest one. Now, are the triangles congruent? And if so, what is the reason? What's one of those four? And right now I see a side, an angle, and an angle.
Yeah. So SAS.
Yeah, this third side is congruent. So yes, that's now you gotta be the order of the letters here does matter. Like if you're looking at the top triangle, TON, it's the side where nothing's congruent, down the side where two is congruent is your path. So you have to sort of start it the same way on the other triangle. Would you attempt to give me those three letters there, please?
Uh, T TYM.
So again, T on the top triangle here on the left, T to O goes down the side where there's nothing.
Right. Okay. NYT.
Yes. NYT is correct. I think that's actually the hardest part. It's easier to sort of write things and all right, let's look at the next one here, letter B. All right, is it a reflection, a rotation, or a translation?
So is any of these, do you see any of these?
Looks like another rotation.
Yeah, about that point R again, or about point right there. Yeah, I would agree.
Um,
Okay,
you know,
so are the triangles congruent? I will tell you they are. What is the reason?
What I've done is just, it's sort of a simulated 3D. These aren't.
Uh, angle, side angle.
Okay, what is the third angle that's congruent? Because I agree, you got an angle and a side, an angle and a side. What's the third angle?
Uh, third.
Right, like there's not a third angle in this drawing as is, but maybe there is one because you can find it.
The like where R is that area.
Now I'm gonna challenge you a little bit here because this has been an area you've struggled in. Can you give me the three letters that refers to this first angle where my cursor is?
JOR.
So JOR is over here. The middle letter is the vertex.
Okay, JRO.
Okay, so angle JRO. Now, similarly to what we'd said about the triangles, your path has to be the same. See how J to R goes down like nothing, or even you could think of it as the hypotenuse.
Yeah.
And then back to down the single side, the single line side. So give me the equivalent angle over here.
ERG.
It's GRE. Yeah. Okay,
No.
good. GRE. All right. Now, no. I let you talk me into that. It's ERG. Maybe that's what you said first. I didn't hear you.
Yeah.
Okay. So it is angle side angle. The letters here you'll find are the same issue with the angles. Like you have to go in that order, like V to R to E. You're starting at the 90-degree, you're going down the single side and you're coming back down the hypotenuse. You have to replicate that on the other triangle.
ROJ.
So you're starting at the 90-degree though. Is R at the 90-degree?
ORJ.
Okay. Let's go to C is probably the easiest because well, I take that back. These are actually these triangles are not congruent. Even though this side is congruent, there is no ASS theorem. So not applicable. Not applicable.
Is there anything that you see being
So you got to be on the lookout that though, because they look congruent. It's like, oh, I got two sides and an angle. That's awesome. Is that okay?
Yeah.
All right. So is it a, but it's still, there could be a reflection, rotation, and or transformation. What do you see?
Looks like a reflection.
Are we just gonna do where the
Over
mountains
what line
gradually scale
segment
bigger?
is it?
Or is it going to be an actual
C.
3D where?
CR.
CR, you got it. Good. All right. Good job on that. All right. Letter D. All right, so these are congruent. I'll let you figure out why, and then also tell me if there's a reflection, rotation, or transformation.
So that's
This was just arbitrary. I wasn't modeling it for anything specific.
right. So that it's not.
Looks like rotation.
Okay, what point is it rotated about?
Like the center of the diagonal.
Okay, I'll yeah. So it's like Jeopardy, they just say, all right, we'll go to our judges. Yeah, that would work. Okay. So why are they congruent? I know you've probably got them on your page. Sometimes it's good to have them up here. And you can also rule some out. You can say, well, I know it's not that. I know it's not that.
I'm thinking maybe it could be a hypotenuse leg.
Okay. So for that, you have to have the hypotenuse congruent. Do you have the hypotenuse congruent?
Yes, I think. Yeah,
It's
that's
shared, so yeah, okay. And then do you have a leg? Not you, but does the triangle have a leg?
yeah.
Good. Okay. Now, most importantly is that order, knit congruent to, and that it's a path. It's always like a, you know, you're charting a course, so you have to go down a certain path.
It looks like a TAN.
Yeah, you said tan, T-A-N.
Yeah.
Good, really good. All right. Any questions, thoughts on that?
No.
Okay. So for problem 3, while it does not require you to draw a triangle, you may find it's extremely useful to draw 2 congruent triangles, label them in exactly the same order, and then answer the question. And if you're not sure what I mean by that, please let me know, but that might be a pretty big hint there.
Hey, Ryan, on that readout, should there be color in it to match? Make sure we have red dots for our bound peaks and so on. Or is that? That necessary?
What do you think here?
Um, EW equals line.
Do we want to unify? Because the upper left, I have
MU.
size circles.
The order does matter.
It's square pixel. We want to
Like
pick
you
one.
went from,
Okay,
yeah. And it's a small thing, but it really is critical in this course. Now, in part B, the single letter, yeah, you're not gonna get that up, but if get that wrong, but if there was like 3 letters to describe the angle, you could have an issue there. But what angle is it congruent to?
E.
It is E. Very good. Any questions on that?
No,
Okay. Do you expect to have all these proofs on your test?
maybe, hopefully not.
Okay. Hope is not a good thing when it comes to tests. Did your teacher say anything about that? Like how many there were going to be on there?
No.
Okay. All right. So this is an example of an overlapping triangle. And so you really want to split them apart here. N, Q, L, and then E, M, E, M, L, like that.
Yeah.
And if you're wondering why those, it's because those are the ones you're trying to prove. Okay, so you've got, I mean, you've got actually a lot here to help with. What statement comes first?
Uh, P or angle P equals or is the first given.
Congruent to angle N. Yeah.
Yeah.
Now, does your teacher accept if you just write A?
Oh, maybe.
Okay,
I
I
think
would
it would
avoid doing,
be.
I was gonna say, I was gonna recommend not doing that. But what you do want to do is actually label the new drawings with that. What's the reason
Given.
given? Yeah. All right, the second one's kind of like, well, okay. LM congruent to LQ. LN, oops, wrong triangle. LM congruent to LQ. All right. Now, typically in an overlapping triangle problem, you have to go back to the original to figure out what's overlapping. And it's either sides or angles that are overlapping.
Like QLM,
So
that that part.
So what I'm seeing here is that the angles are overlapping,
based off of
which is less common, but that is the one.
considering I know that style.
Oh yeah, that's what I was trying to.
Now, this is the hard part. This is the you have to give the two angles. Like you can't just say angle L equals angle L or congruent. You have to actually use the letters, but you have to create the path. Like, is it N to L to Q? Is it Q to L to N? And then you have to do the right one here. Oh, actually, your teacher doesn't do that. Never mind. Silly
Yeah,
me.
it's listed there.
Well, that's not right, but that's okay. That's the reflexive property. That's fine. All right, and then your proof statement is triangle NLQ congruent to triangle PLM. What is the reason for that?
So I would assume
ASS.
You're just getting sure there's no ASS theorem.
but it is also very
May-
Right, AAS.
Yes.
there may be something that I just
All right.
that's my rough. But it definitely would like to.
All right. Any thoughts on that before we move on?
No.
Okay. Are you turning this review in, or is it just for your benefit when you practice?
Yeah, just for benefit.
Okay. All right. BD bisects angle AEC. So it's bisecting the big angle up here. What does that tell you about angle 3 and angle 4 if the big angle is bisected? What's the meaning if you cut something in half?
Oh, there's two things now. Cut.
Okay,
The
what do we
two
know about
things
that?
are equal.
They're congruent. Yeah. Okay. So the first thing is given. BD bisects angle ABC. Angle 3 is congruent to angle 4 by definition of an angle bisector. And you'll see that like one leads to the next. All right. What about this next line? BD perpendicular to AC.
What they have is most part.
Um, definition of perpendicular angles things.
So that's what the goal I would say. That's
Okay. It's given, right?
Oh wait, hold on. Right.
Don't always make sure you just, okay, they're both given. Great. All right. So now if they're perpendicular, that leads to the next part. Tell me what goes there.
Do you think that we'll still be able to work it? Obviously, I know you're only going to have to work in the 8 because that's the days that you're available.
That is definition of perpendicular. right.
The rest of it.
Good job. Okay, now I'm not, oh, there it is, okay. Now it's not enough to say that they're right angles. You have to then say that they are congruent. Angle 1 is congruent to angle 2,
There's no reason.
because all right angles are congruent. And what I've not been doing here, and I should have done this, is like this, we should have labeled that, okay, those are congruent. We've now said that angle 1 and angle 2 are congruent, because we do have to prove the triangle's congruent at some point. So at some point you want to actually go back and label the triangle appropriately.
Um,
Okay, what's next here? BD congruent to BD. Why is that the case?
Oh, because it's like it's the part in the middle. The
Look at your list down here. Make sure you grab the right
let's
wording.
see,
with this,
reflexive property.
Yeah.
so
Okay. So the sides right down the middle are congruent. Why are the triangles congruent?
for this first part, sure.
Like you got to look at what you have in your drawing for each triangle.
Angle, side
Yeah,
angle.
we have all these pieces. I did have one question for Teresa. In the pencils of the keyframes, we have two different cockpit views.
Great.
Was that
So now the
intentional?
triangles
You
are
need two
congruent.
different?
CP/CTC always follows triangle congruence. You can put your proof statement in at the end,
Four and
like that.
yeah, it can. Yeah,
Is that okay?
Yeah.
the
All right.
box. Okay. So we just need one cockpit that works in both frames. All right, easy.
Okay. This is another overlapping triangles problem. It would be really good to draw the overlapping triangles off to the side with the correct letters. And I have not even done that. Boy, that's terrible. All right, there we go.
Okay. Right. Now, Alec, if you're gonna create these mountains in your 3D software, is that an easy task to throw in color bands?
Okay, what should we start with here? What goes in the first?
Gibbons.
Yes, so JK congruent to ML, and then angle JKL congruent to MLK. JK congruent to ML. Could you appropriately label, well, they've actually already done it for you, so that's not going to be, that angle is congruent to that angle. What is next?
Sorry, say that again.
what comes next? I mean, you know, and if you're not sure, go down, like look at these or what do you see in the drawing? You know, that's um,
KL equals KL.
good. It's always that overlapping piece and the order switches. Oh, your teacher doesn't like, okay. All right, well, it's reflexive. So property. From there, you can now prove that the triangles are congruent. JKL congruent to triangle MLK. What is the reason?
Side angle side.
Side angle side is correct. SAS, little SAS. All right, very good. So it looks like your teacher's more emphasizing these overlapping problems. Please try to use the strategy we talked about there to help with those. Ready to move on to the next one?
Yeah.
All right, so no need to redraw these. You'll start noticing the more you do these that like anything where there's overlapping stuff, you're probably going to use like that AC congruent to AC. But we'll start with the givens here. BC congruent to BC. BC congruent to BC. Those are congruent and that's given. Angle B, angle B are right angles. That's also a given.
Yep.
Okay, so angle D. Now it's not enough to just say they're right angles for congruence. You actually have to say that they are congruent if you want to use that. And I think you do.
Yeah.
So what is the next next line based on their fact that they're right angles and we want to show that they're congruent?
Um. Definition of right angles.
Nope. That's the reason. Well, that is the reason. So which well, there's only one. You see how F is, oh, I guess F. I apologize. I guess. I guess the teacher doesn't need you to say that. That's one of the things that makes these a little bit more challenging when you think you know what the direction to go. It looks like you're going to use hypotenuse leg. So you then have to say that they're right triangles, not that they're the right angles are congruent. Because we already used A, B and B are right angles. So yeah, so I think your definition of right triangles is there. And then you have to say that they are right triangles. CDA, triangle CBA are right triangles. That one, that letter I there. So now that we have the right triangles, we're going to use hypotenuse leg. That's kind of a standard thing. So what are we missing to prove with hypotenuse leg? Do we have the hypotenuse? Do we have a leg in the triangles?
Yes.
Which one do we have? We have one, but not the other at the moment.
Like,
You've got a leg, yeah. The CD, CB, those are legs. So you need the hypotenuse. Which segment is the hypotenuse?
the center, like CA.
Okay. Yeah, there you go. So you got AC congruent to AC. What is the reason for that?
Reflexive property.
Reflexive property, yeah. We'll just keep going in order here. Probably finish this one. Be tight here. So always a good idea to kind of throw all the givens on there. But you don't necessarily have to, because this one, it the instructor uses the given. L is the midpoint of JM. They use that in statement 2.
That is the given.
Right? Agreed. So now what does that mean? It means that it's right in the middle, but what does it tell you about the pieces?
They are congruent.
They're congruent. So JL is congruent to LM. And that's a definition of a midpoint. And it's very common that when they tell you like something is the midpoint or the angle bisector or the perpendicular, that use the definition of that in the next line. So now if JM bisect KN, that's this one bisects this other one. What do you know about the pieces again? The segments.
They are, they're congruent.
They're congruent, yeah, so KL
Yeah.
is congruent to LN. And that's the definition of a segment bisector. All right, so we're in good shape here. You do want to prove the triangle's congruent, but you don't have enough for it. You just have two sides. What would be the next step to prove? Like, what else do you see that's congruent in the triangle?
The angle, next to L.
Okay, so you got, I guess you only have one option there. Oh, nope, you do have, so it looks like your teacher, I don't really know what your teacher, how your teacher wants it. Usually you just say the two angles are congruent, vertical angles are congruent. I don't know if your teacher wants it in two steps. I kind of think they do. You might have to refer to your notes there about that. But the net result is that the angles are congruent. And it does kind of look like that because to prove that triangle JLK is congruent to triangle MLN using side angle side. It looks like they do leave you two places for that because this is CP CTC for angle J congruent to angle M. So it looks like you have to first say that they're vertical angles. You have to say that angle JLK, angle MLN are vertical angles. And that's I guess definition of vertical angles. And then you can say that they're congruent. You can say that angle JLK is congruent to angle MLN. Or maybe that is the definition of vertical angles. I'm not sure. It's really like vertical angles theorem, maybe. Something like that, you know. That'll get you pretty close to this. All right, make sure